prerequisites of this course? Well, there is no assumption that you have any knowledge about databases. The whole point of this course is to get you started from ground zero and then get you up to speed in order to get to do some basic tasks like how to store some data, how to query the data, and so on and so forth. So sit back and relax. This is just, if you're just getting started, this is the course for you. So what to expect from this course? Well, we will not be covering any advanced concepts in this course, right? We will just look at some basic stuff like what is data, how do we store data, how do we join tables, just so that maybe you're looking for an interview where they ask some basic SQL skills and you just want to get started with or get some knowledge about how to go about with this SQL thing and how to go about with this database things and so on and so forth. And at the end of this course, you will be comfortable writing some basic queries, writing some aggregations and so on and so forth, which will just cover some basics and not some advanced stuff. So that'll be the overall takeaway from this course. So let's get started. So let's look at the very basic definition of a database. When I pull up Wikipedia, it says that a database is an organized collection of data, right? So data is around us, right? We are submerged in data. Anywhere you see, you look at a airline booking, or you look at maybe Amazon.com, you have a lot of products listed and so on and so forth. So all this is just data around us. So it says that a database is an organized collection of data. Now, this is really very tricky because when you say an organized collection, how do you really put this data and in what format? And if you look at the second sentence, it says that it is a collection of tables, queries, reports, views, and other objects. And we will go through this in more details, right, in the further slides. But basically, you can represent data, you can put it into tables, and you can write some queries against these tables in order to retrieve the data that you have just stored. Proceeding, the data is typically organized to model aspects of reality in a way that supports processes requiring information, such as modeling the availability of rooms in a hotel in a way that supports finding a hotel with vacancies. Now, let's not get too much into this, but the bottom line is that when you store data, you should have some use to retrieve it, right? I mean, you are storing data so that you can query the data and get some information out of it. Now, the way that you store the data is extremely critical because you don't want to store the data in a format that you can't really write an easy query, right? The bottom line is you should be able to retrieve the data. And there are various models to store this data, and we won't be going too much in depth. We'll take a very simple concept, let's get started, and then we will slowly start adding more and more information to it. So even before we take a deep dive, let's look at some basic airline booking data. So when you go to a website and book for any flight ticket, you enter in certain information. You enter your first name, last name, age, and stuff, right? And basically it stores an itinerary ID or a booking ID or whatever you call it. Now, where does this store it, right? So the company will have a database which will take in all this information and store it in the database. Now, when we talked about retrieval, accessing, and stuff, where does this come into play? Imagine one fine day you call up customer service and say that, oh, I have a problem with my airline booking. Can you help me out with this? So the customer service agent, first of all, asks you for, oh, can you give me a booking ID? And immediately he pulls up your records. Now what he's doing is that he's typing in the booking ID into an application which talks to the database and just pulls up your record which matches the booking ID equal to whatever you gave him. So this is typically how a querying works. So there are specialized syntax for it, which will help you talk to a database in order to just get the information that you need. And we will be precisely looking at all these different commonly used query and their syntax. Now, when we talk about databases, there are various companies who provide their flavors of databases. You will hear terms like Oracle, SQL Server, and so on and so forth. Now, this course is basically not meant to concentrate more on who is the vendor and stuff. We'll just take, maybe SQL Server, run some basic queries against it. Now, the same syntax, most of the time, 99% of the syntax generally applies to all the commonly available vendors, right? In any case, we aren't going to go too much in advance. So at least the basic querying that you would need would be really covered here, which will help you quickly get started, and you can really adapt to whatever vendor you're looking forward to work with. All right, let's take one more example, right? You are joining as maybe an analyst, and your boss comes to you and asks, okay, pull the total gross booking amount for 2015, right? Now, let's assume the way it is stored in the database is something like this. So you have a booking number, you have a gross amount, and you have the date of booking. So basically what he's asking you to do is actually give you a total amount, total gross bookings for 2015. So there are two parts to it. You need data only for 2015, and you need the amounts to be added up, meaning you need something like this, right? So this is where your query comes into play. Your query will be designed in such a way which says that out of this database, just give me entries for 2015, and whatever is returned, just add it up and give the answer to me, right? So this is one of the areas where effective querying will help you. Now, before we go into too much of tables, queries, and stuff like that, let's take a step back. Let's see what can we store in a database, right? Database is nothing but a container which will store all your data, and you can arrange those data in tables, views, and stuff like that, and we'll go into it in detail. First is text, right? You saw in our previous slide that you stored your first name, last name, etc. So basically you can store text. You can store numbers. We saw the booking amounts, gross amounts, right? So you can actually store numbers, decimals, and stuff like that. Images, of course, there are various ways to store this in binary format and so on and so forth. There are various querying techniques in order to retrieve the information that you need. Now, again, this is just 3 examples I have given you, and there are tons of other stuff you can store in a database. You can store XML and stuff like that, and there are various syntax specially designed to retrieve that kind of information. Let's just keep it simple for this course. Okay, how do we store this data? First of all, we need to understand what the data needs to be stored. Right, we need to do a deep analysis of what that data is, right? Is it something that you're going to be querying? Is it something that you just need to be archived? Is it just something like an ebook, right, where you need to store, right? So that basically takes us to a very different world of structured data, unstructured data, and so on and so forth. In this course, we will be just talking about structured data. Structured means nothing but the data that fits into tables. Okay. So accordingly, once we realize what our data is, then we accordingly design some tables, because after all, we need some way to query it, right? So we need to have a perfectly designed table so that it's really easy for you to query it. And believe me, this is a very simple task. And then we issue some queries to it in order to retrieve our data. And that's it. So basically, it's a 3-step process. Create a database, put some tables in it, store some data in it, and query it. Again, I have really simplified this. There are lots of inbuilt stuff, lots of stuff that you need to do or you can do. And again, those are some things that we will not be covering in this course, but at least the basic things would definitely be covered in this. All right, so let's put it all together. So let's take the example of an airline database. You create an airline database, then you create tables according to your data. So let's assume you need a table for storing, say, reservation related data, right? You create a table with reservation details. Next, you create a detailed table for passengers. So say you stored their first name, last name, things like that. Next, say flight information. You have your takeoff time, your flight numbers, and some other data, right? Now, a person if he wants some data, he would actually query these tables and get the data, right? He can directly query the reservation table or the passenger table or a combination of both reservation and passenger to see which passengers reserved, which flights, things like that, right? And that's where the concept of joins and stuff will come into play. Again, it's super simple concepts. We'll take it step by step. All right. So in the last few slides, in the last 20 minutes or so, we looked at how to create a database. We discussed what is a database, what all data can go into a database, how do you organize the data in the form of tables. We also looked at some basic installation about your, for your work environment. And we also looked at some very simple queries like, how to query the data from a particular table, how to create a table, how to create a database, how to insert some data, and so on and so forth. Going forward, what we'll do is we will actually take a deep dive into querying. We'll look at various syntax, right? We'll look at aggregation, how to query a single table, how to conditionally query a single table, how to join multiple tables, and so on and so forth. We'll start with, again, very simple stuff. We'll keep on adding information. And I will be taking a little bit different approach from here onwards. What we'll do is, instead of me going through a syntax and then showing you, let's take a good database like which has certain number of tables and data, and let's just discuss some problem statement, something like give me all the employees who were hired after so and so date, and let's see how can we create a query for them. So it will kind of give you a real world aspect of when questions are asked, how do you go about approaching those kind of problems. So what we'll do is, Microsoft provides some sample databases. We're going to go ahead and install that. The reason being, we don't have to create data. That's pretty much a good list of tables, good list of data. It's something related, something like a real world data. They call it the AdventureWorks database. It's actually a very simple installation. We just download it and then just attach the databases into our database engine, and then we can start querying it. I'll precisely show you how to do that. It's a very simple procedure. And then we'll look at certain things like querying a single table, then we'll look at some conditional querying, and then we'll look at some where clauses, and so on and so forth. So let's go ahead. All right, so what I'm going to do is, again, I'm going to just Google AdventureWorks, and let's see. Okay, so here are some product samples. It is provided by msftdbprod-samples.codeplex.com. Let's go ahead and see what all it provides. Okay, let's go ahead and download this, and let's see. So we are using a 2014 version, so 2012 should be compatible. Let's go ahead and save this, and I already have this saved, but let's see, let's just call this as _1, and then let's save this. It's a small file. It's about 36 MB, I believe. Let's see, yeah, around 36 MB, and so let's download that. And in parallel, I'll also open my management studio. Okay, and let me connect to my database, and again you'll find the two databases that we created in our previous session. Now this has downloaded, so I'm going to go ahead and just unzip this here, and once I unzip this, you should find two tables. The MDF file is your actual database file. LDF file is where it stores logs. So don't worry too much about it right now, and we will just go ahead and use this. Let me just go ahead and put this into a different folder. And all right, so I am going to use this path, and let me go ahead and right click on databases and say attach. Once I click on attach, it's going to ask me my MDF file location, and I'm going to just input my MDF file location. Okay, so let's say okay, and it'll also pick up the LDF file, and let's click OK, and then you should see your database restored here. If you open up the tables, you will find a lot of data that they provide you. So let's select the top 1000 rows, and you see that there is some inbuilt data to play with. Now this actually gives us some base work to play with data. and we'll precisely use the same database. And if you want to follow along with me, go ahead and download this database and attach it to your local environment, and then you can follow the queries along with me. Welcome back. So in this session, what we'll be doing is we will be taking a different approach. We will be discussing some problem statements, and we'll try to write some query against it. So what we'll do is we will cover some concepts by directly writing queries against our AdventureWorks database. So let's get started. I'm going to click on New Query, and let's just make sure we are using the right database. All right. Okay, let's get started. Now, let's look at some tables first, right? Let's look at the department table and write a select query. So select name, or let's say select star from human resources department. So star generally means that give me everything, all the columns. So if you look at our columns, we have 4 columns. Star will just give you everything. Just highlight that, press F5, and you can look at some sample data over here. So it has about 16 rows, and let's write some queries against them. So let's start with something simple. Let's say show me all the department names. By the way, you see the 2 dash I have put over here? That basically says that this is a comment, right? I mean, these statements will not be executed, and these are just plain comments where you put it in front of your code so that you can understand your code a little bit more better. And this can be any text. So let's proceed. Select name from human resources department, and let's see what it gives us. So it should give us only the names. All right, let's proceed. How about we get all the groups? Show me all the groups. So groups is basically stored in this group name. So basically what we are going to do is select group name from human resources department. So you get the idea by now, right? You use the word select followed by the column names, and then you specify the table name in order to get the results. And again, just to reiterate, the ones you see in blue are the inbuilt keywords. All right. Now I wanted to introduce you to a keyword called distinct. Now if you look at the group names, you see a lot of repetitions, right? It just gives you all the rows. But what if I asked you just give me the distinct values from here? Don't repeat it, right? So something like this. Show me all the distinct group names. And this is where the keyword distinct comes handy. So you say select distinct group name from human resources department. You see that it gives you just a unique set of values. Cool. Now I want to introduce you to filtering. This is where we use the where clause. So let's actually look at all the data once more, and by the way, you can selectively just highlight what you want in the query, and then click or press F5 to execute that part of the query. So this is our overall data, and let's say if we just want to look at any record that has the word manufacturing in it. So you see we have record number 7, 8, and probably that's it. So this is where our where clause comes handy. So show me all the department names who are part of manufacturing, right? So the way you do it is select, let's choose name and group name, right, from our adventurebugs.humanresources.department, and where we say that where group name, we introduce a keyword called like. Like is basically, you say that the group name should match the word manufacturing. Now this is more likely, we call it as an exact match. So it's going to look at the column group name and it's going to see if it has a value called manufacturing. Let's see what it gives us. So it gives us 2 rows, right? Now, okay. Now let's, since we have introduced where clauses, let's basically, play around a little bit with where clauses, right? You see that we filtered by using a text. Let's filter by using some integers as well. So let's just so that it doesn't get too boring, let's choose some other table. So let's say give me all the employees from the employee table. We have an employee table here. So I'm going to just write a query called select star from human resources.employee. I'm going to press F5 and this gives us about 290 rows. So you see here it's about 290 rows and it has a bunch of information. Okay, now let's play around with a where clause. Okay, let's say give me a list of say all employees who have org level, you see the organization level, equal to 2, right? So here we are filtering based on an integer. Let's see how to write that. Select star from human resources.employee where organization level equal to 2. So you see for an integer we use the sign equal to, and for text we use the keyword like. Okay, let's see what this gives us. So you see that it gives us only the rows that have an organizational level equal to 2. Perfect. Now let me slightly modify this. Let me say give me a list of all employees who have org level equal to 2 or 3. You see there are two conditions I have put here, right? Okay, let's see how we go about writing this. We say select star from human resources.employee, these things remain the same, where organization level in 2, 3. So we introduce the keyword in here. Basically it says that you have a list and give me all the rows which match this criteria. Let's see what it gives us. So sure enough, it gives us all records which have an organization level as 2 or 3, right? Perfect. Okay, now let's take one more example of a text value just so that we get some practice. Let's say we need okay, let me just look at the data once more. Okay, let's choose this row, facilities manager. So let's say give me a list of employees who have a title as facilities manager. So by now you must have figured out we write select star from human resources.employee where job title, so should it be equal or should it be like? Now we are going to use a text match here, so we'll use the keyword like. facilities manager. So sure enough, it just gives us one row. Now, what happens if I don't match the casing? If I write something like this, facilities manager, all uppercase, what do you think will happen here? Let's find out. You see that still it gave you that one row back. This means that this is not case sensitive. You can pretty much, use any casing, and basically if the text matches, it's going to give you that record back. Okay, now one thing you find over here is you're doing something called as an exact match, meaning whatever you have given here should exactly match with the job title. Let's try something else. You see, I put 2 spaces in the end. So what it is doing is it is trying to match from the set of records the keyword facilities manager space space. And there is no record like that because it's doing an exact match. What if I told you there is a wildcard where you say that, okay, give me all the records that at least have the word manager in it. I don't really care whether it's facilities manager or any other manager. So the way you do that is using a wildcard. So let's say something like this. Give me all the employees who have a title, or let's say who have the word manager in their title, right? How about that? So we say select star from human resources where job title like manager. Now would this give us any result at all? No. Let's see. It won't, because it's basically checking for an exact match, right? But what we need is we need to get all the records that basically have that keyword wherever it is, but basically it should have the word manager in its job title. So we introduce something called as a wildcard. It's a %sign. This basically says that anything can be before the word manager, but nothing should be after the word manager, right? So if we execute this, you see that the % is anything that is before the word manager and there's nothing after the word manager, right? So this is how you this is how you do pattern matching. Now let's look at one more example. You see the job title production control manager, document control manager. Let's say we want to basically return all the records that have the word control, right? And anything can be before and after the word control. The way you do this is control, and after control you put a %sign, which means that anything can be before the word control and anything can be after the word control, but you need to have the word control in your job title. Let's look at this. See, this is how you, so in this case there is nothing, and that's also a perfectly valid scenario, right? And you see this is how the pattern matching happens. So this is kind of playing around with how to filter your data using text and using integers. All right, so let's go further. Now I want to introduce you to a little bit more where clauses, but we'll be trying to filter out some dates, right? We have here birth date, hire date. Let's try to play around with them. We'll have a separate session on how to manipulate dates, but here the point of the next few queries is just to see what are the possibilities to filter out dates. Okay, now let's just look at the entire data set. Okay, now let's say we want to get all employees who are born after, say, 1st of January 1980. So how do we do that? So give me all employees who are born after Jan 1, 1980. How do we do that? Again, this will give us all the employees, but we need to add a filter. So we say where birth date, and this is where we introduce the greater than sign, greater than month, date, 1980. Let's see what this does. So sure enough, you see that it's kind of filtered all the data and given you all the records which match this criteria, where the birth date is greater than 1st of January 1980. Perfect. All right. How about now we play around with some date ranges, right? We say that give me all the employees who are born between 1970 and 1980. Let's see how that looks like. So give me all employees who are born between Jan 1, 1970 and Jan 1, 1980. So how do we go about doing that? So one of the ways is using, of course, you can say that where birth date is greater than 1st January 1970 and birth date I think I should just make this correction quickly here, is less than 1st of January 1980, right? So this will give you that range. SQL Server also provides you another inbuilt keyword to do this. So you say that select, let me just copy paste this part, and that's called as the between clause. So you say birth date between 1/1/1970 and 1/1/1980. So it's going to look between these dates and return the results to you. So you see that all are between 1970 and 1980. Okay, so I think you must have got a good understanding of some of the key concepts here. What we will do is we will look at some advanced concepts now. We'll look at some ordering clauses, how to order your data in ascending order, how to order your data in descending order, how to join tables, how to run some aggregations, and so on and so forth. Okay, so in the last few minutes we saw a couple of queries, and let's just continue and add more and more concepts. So let's take a quick revision of what we discussed so far. We looked at the select everything. So where we use a select star, it'll just give you everything from the table. Then we looked at some filtering aspects where we said that for text use the like operator. We also looked at some filtering where your filter criteria is an integer where we use the equal to. We also tried filtering based on a list of values, so where we use the in clause. Then we looked at how to filter based on certain text, right? Full match criteria kind of a thing. Then when we also looked at how to filter based on partial criteria, we used the percentage sign, an exact match versus a non-exact match. Then we played around with dates a little bit. We used a greater than, where we filtered our data based on birth date greater than 1980. We also looked at how to use ranges, and we also looked at an example where we use the between clause to specify two dates between which you want to filter. Okay, so let's proceed. Here I wanted to throw in a new concept called as calculated columns. And as the name suggests, it's nothing but you introduce a third column which is not a part of the table based on certain columns that the table already has, right? So for example, if a table has the quantity and the prices for each quantity, you could perhaps introduce a third column and call it as whatever, quantity multiplied by the price, something like that. So let's have a look at some examples. So let's select some of the tables so that again it doesn't get too boring. So let's see if we can use the product table. Let's see what it has. So select star from production.product. Let's see what it has. Again, let me just quickly enter my password. Oops, need to remember this. Okay, so here we have some good data, and we have list price. Okay, so let's look at some narrow range. Let's look at the name and the list price, so that we don't look at all the infinite number of columns that this table has. Okay, so a calculated column is nothing but something that you introduce. So you say select name, list price, and let's say you want to introduce a third column and you want to just give a $10 increase to the list price. So you say list price plus 10. And this is where our concept of alias comes into place. Alias is nothing but any name that you can give to a column, and I'll call this as, say, adjusted list price. You can call it anything. I'm just calling it adjusted list price, and from production.product. Okay, let's see how this looks like. Okay, so if you see that these two are the columns that the table provides. This is basically a column that you introduced, and what you basically did was that whatever was in list price, you just added $10 to it. Okay, so sometimes these things can be really very handy, and as and when you start writing more complex queries, you feel that these things can really help you a lot to put your logic in certain columns, your inbuilt logic or the logic that you have derived into certain columns for easier querying. Okay, now since we have started to manipulate and introduce stuff, I will introduce you to a few statements that can help you create tables, delete tables, and update tables. We looked at something very simple in our previous lesson, where we just wrote insert into something, values, blah, 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 and it created a table. Here we are going to take a slightly different approach. Okay, what I want is, so this statement which I have highlighted just displays the result, right? It's not stored anywhere. What I want is actually to store this in a separate table. So how do I do that? We introduce something called as an into clause. So the way it works is you write your logic, right? And then you say whatever is the value you insert into a table, right? You can give some table name. Let's call this as production.product_2. Now, please note that this table doesn't exist right now. So what it is going to do is it's going to execute this query, and whatever are the values that are returned, it's going to put it into this table. Okay, so let's complete this. Now, first question is, when this table is created, where will it be placed, in which database? Well, it depends on what context you are running. Right now you are running under AdventureWorks 2012, so it will actually create a table under AdventureWorks 2012. So let me try executing this query. Okay, so 504 rows affected. Now if we refresh our tables, we should find a new table called product2 that has been newly created. Now let's run a select star from production.product2. Now if you see, there's a third column introduced here. This was not a part of the product table, but you wrote your query in such a way that you introduced the third column, and the total results of this table is actually pushed into this table called product_2. And this is where certain introducing such tables and calculations might become very handy. So imagine that you have a lot of complex logic, right? And you want to break it down into steps. You can keep putting this into separate tables and perform calculations. Now I can perform some calculations on this table, product 2, and I can put that results into another table, right? And in this course, we might not go in too much depth about temporary tables and permanent tables, but let me just give you a very high level overview of that. What we just created is a permanent table, meaning this table is actually stored in the database. Whoever connects this database can actually view this table, right? There is a second form of table that you can create called as temporary table. Temporary table, let me show you. Let me push this result into another table. Here, what I'm going to do is I'm going to write hash followed by a table name, and I'll call this as, say, temp table, temp name, something like this. This hash actually tells SQL Server that whatever table it's going to create should be a temporary table. Temporary table meaning this table is visible only for you. It's just a very rough table for you. As soon as you end this session, meaning if you just close this window or open a new connection, this table will just vanish, right? You'll not have access to this table. So it's kind of, if you have again some complex logic where you just want to push some results to a temporary table, work with the temporary table, and then finally dispose of the table, that's where, that's one of the places where temp tables can really be useful. Let's try to run this query. So 504 rows affected. Now if I write select star from hash temp name, you will find those values, right? Now, as I said, this is a temporary table. If I open a new session, right, and run this query in this new session, it will actually say invalid object name, because in this session it cannot see your temporary variable, a temporary table that you created, right? So just you need to be a little careful when you're using these things. Okay, we looked at how to push data into a table. Let's look at how to delete data from a table. Now this is actually super simple. Let's play around with our new table that we introduced, the product underscore 2. Let's say you want to delete the row that has a name called bearing ball, right? So the way you do it is delete is an inbuilt keyword. You say delete from my table, you give the table name, and then you just filter on the rows where you want the deletion to occur. So delete from product 2 where name, like, we used the like operator right before when we were working with text, bearing ball. Now one thing to note here is it's going to do an exact match here, right? We don't have the % sign or something, so it's going to actually look for the word called bearing ball and going to delete that row completely. Let's give it a try. It says one row affected, which means there was at least one row which matched this criteria. Now if I run a select star from this table, you will not find that bearing ball row. See? Now since we didn't use a partial match, there are some rows which have at least that word called ball bearings, but it will not get deleted. But you get the idea. Okay, and finally I also wanted to tell you something about an update statement. An update statement is nothing but something that updates a given table, a given row, right? So let's run through an example. The way you write it is using the keyword update followed by your table name. So it basically says that update this table, and then you give a condition as to what should be the update and which rows should it affect. So you say set name equal to, let's say update this one, blade, right? Set name equal to blade underscore new. I'll just call it new. The updated value should be new, where name like blade blade Okay, now please note you are assigning this new value to this column, so that's why we don't use the like operator here. What we are saying is update this table where name is Blade, and whatever rows qualify that criteria, just update the name to Blade_new. Let's see what happens now. It says one criteria matched one of the rows matched your criteria, and then we say select star from production.product2, and we should find our updated value here. See, there you go. So this is like a high level overview of how you would insert some data, delete some data and update some data. And again, these kind of temp tables and permanent tables really help you when you have super complex logic and you just want to cut them into smaller pieces and then work with smaller tables, kind of a thing. The other criteria where I could think of is I was working with a table recently which had like millions and millions of rows, and I just wanted to do some analysis on a portion of the data, right? One way is of course to use where clauses and stuff like that, but what I did was that I just pushed 1,000 rows from there into a temp tables and I worked with it. It's just more faster. So depending upon what things you use, you might want to use a temp table or a permanent table, and so on and so forth. So in the last few sessions, we have been seeing how to query some tables. But if you observe, we have always queried via a single table, right? We have not referenced 2 or 3 tables. We just fire our queries against a single table. Now, in real world, most likely you will have to query multiple tables together, right? Data is actually shared across multiple tables, and that's where we use the concept of joins. So joins is nothing but it's a syntax, it's a query which helps you join 2 or more tables based on certain criteria, right? When 2 or more tables are to be joined, there will be at least one column which is common across both the tables, and we'll look at a few examples. And this is one of the most commonly occurring scenarios where we have to join 2 or more tables. So depending upon what kind of data you want to retrieve, in the sense if you're joining table 1 and table 2, do you need just the common rows, or just the rows which are from table 1 and which is matching from table 2, and various scenarios. There are certain types of joins that are introduced. So we'll go through them one by one. We'll look at some visual examples, and then what we'll do is we will take our AdventureWorks database and actually write some queries, so you can get to see in real world how does this happen. All right, so there are 3 types. Mainly there are 3 types of joins. One is an inner join, next is an outer join, and third is a cross join. Let's look at them one by one. Okay, inner join. Let's assume you have a table which is pretty simple. Okay, you have an employee ID column, the first name and the last name. Pretty simple table. But you have a second table called as, say, which just stores the salary of employees, right? So it has an employee ID and a salary. Now, what if I asked you, give me all the employees, their first name, last name, and the salary? In the previous sessions, when we had to do something like this, we would have expected that the salary column is in the same table. But here we are seeing it's in 2 different tables, right? So that means there should be some way in which we could join these 2 tables and get our results. Now, if you observe closely, you see that employee ID is common across both the tables. So I can say that employee 1, whose first name is Michael, would have a salary as 10,000 because the same employee ID is referenced in the second table. And that's where the concept of joins really becomes very interesting. Now, the speciality of this inner join, this type of join, is that you will only get the rows which are common across both the tables, right? In this case, there are 3 rows that are common across both the tables, and that's what will be returned. The thing is that there should be at least one match between both the tables, right? In this case, employee ID 1, 2, and 3 are perfect matches between both the tables, and you will get 3 rows when you inner join these 2 tables. Don't worry, we will look at an example where this will be more and more clear to you. Okay, let's look at outer joins. Okay, let's consider a table, right, which has employee ID, first name, and last name. Let's look at another table which again has an employee ID and the salary. This is pretty much the same scenario that we discussed in the previous slide, but here we are just taking a very slightly different approach. We are going to introduce a new concept called as outer joins. We introduce a third table which stores employee ID and phone number. Now, what is interesting in these 3 tables? In a previous slide, we saw that table 1 and 2 had the exact number of rows, right? You had employee ID 1, 2, 3, employee ID 1, 2, 3 in both the tables. Here we are introducing a third table called as phone number, right? But you see that employee ID 3 is missing here, right? Employee ID 3 doesn't have a phone number, and hence they haven't even entered in the table. Now, what if I told you give me all the employees and their phone number if they have them, right? So one of your answers would be, okay, let's join table number 1 and table number 3. But in inner join, as I mentioned before, only the common rows will be accounted for. Meaning if you inner join table 1 and table 3, you will get employee ID 1 and 2, but not 3, because there is no entry for employee ID 3 in table 3. I hope you're getting the difference. Here we are not talking about common rows, right? And that's where the concept of outer join comes into play. So let's introduce the concept of left outer joins, right? Okay, let's take a table which is very simple: employee ID, first name, and last name. Let's take another table, employee ID and phone number. Pretty much the same thing that we just discussed in our previous slide. Now, what happens when I left join table 1 with table 2? Left join basically says that give me all the rows of table 1. Okay, give me all the rows of table 1 and also give me all the common rows of table 2, right? But if you don't find a common row, if you don't find a join, just replace by null. Might be confusing. Let's look at the results. So you see employee ID 1 and 2 are common across both the tables. So it perfectly joined. You would have got 2 rows if you had just inner joined both these tables. But a left outer join basically says take everything from the left side table, whatever is your left side table. In this case, it is table 1. Take everything, right? Take whatever you can join from table 2, that is the right side table, and whatever you cannot join, put a null over there. So in this case, if you see employee ID 3 is not present in table 2, so it cannot join, so it simply put a null in the phone number column. If we have to imagine this a little bit visually, you say take everything from table 1 and all things that are common, right? And then whatever didn't match, replace it with a null. All rows from left table included, non-matched entries from right table will have null. Okay, so this is the main difference. Let's just take a step back. What is inner join? Inner join, just look for common rows. What is an outer join? Especially a left outer join. Take everything from the left hand side table. Take everything which matches with the right hand side table, and the ones that does not match, just replace it with a null. Okay, let's look at something different. Right outer join, it's exactly the opposite. So let's take another example. Table 1, 2 rows, 2 columns, employee ID and parking spots, right? Then you have table 2, which stores employee ID and employee names. Now, how would you join these 2 tables? Employee ID is the common column which will help us join these 2 tables. But if you look at the right hand side table, it has 2 extra rows for employee ID 3 and employee ID 4, right? Now, if I right outer join, what will happen? table 1 right join table 2, meaning take everything from table 2, and whatever matches with table 1, substitute the values. Whatever does not match, put a null, right? So that's the basic difference. When you have a left outer join, that means take everything from the left table. When you have a right outer join, take everything from the right table. So that's the major difference. So all rows from right table included, non-matched entries from left table will have null. Now if we look at this visually, you see that everything from table 2 is included plus the common rows, and whatever is left out is substituted as null. So three concepts: inner join is nothing but just look at the common rows. Left outer join, nothing but take everything from the left hand table, whatever matches, get the values. Whatever does not match with the right table, substitute a null. Exactly opposite is the right outer join. Take everything from the right hand side table, whatever matches, join it. Whatever does not match with the left table, just substitute a null. Again, we will look at more and more examples, so don't worry. Okay, we looked at left outer join, we looked at right outer join. Now let's introduce another concept called as a full outer join. Now full outer join is actually pretty simple. It's basically a combination of what we studied before for left outer join and right outer join, right? So we take everything from left hand side table, whatever matches, take it from right hand side, substitute by null, and do the same thing for the right hand side table. Let us look at an example. So table 1, just two columns. Column 1, customer ID and customer name. Table 2, 4 columns over here. I'm sorry, 3 columns but 4 rows over here. You have an order number, order name, and customer ID. So which is the common column across both the tables? It is customer ID, right? So now just imagine what will you do if table 1 left joined with table 2, meaning you'll have everything from here 1 and 3. So, and whatever does not match, it will be substituted as null, right? Now let's look at how things change when we do a full outer join. We take, first of all, we take all common rows, right? So when table 1 is full outer joined with table 2, the customer ID 1 is common, so you take the common set of information. Okay, now customer ID 3 is not there in table 2, so you substitute by null. Okay, now do the same thing from table 2. Let's look at customer ID 2. The information is not present in table 1, so we substitute a null. Similarly, we follow for all the rows. So basically it's a combination of your left outer join and right outer join. So you will have all rows from your left hand side table and all rows from your right hand side table. Whatever matches, you will find a complete row set. Whatever does not match will simply have nulls. Okay, so all rows from your left and right table are included. Non-matched entries from left and right table will have null. So if we were to look at this a little bit visually, this is how it will look like. You'll have everything from table 1 plus common rows plus everything from table 2. Again, we will look at some examples which will make it more and more clear. But the bottom line is it's just a combination of left outer join and right outer join. And in the end, let us introduce one more called as a cross join. Take an example. Table 1, 2 columns. Table 2, 2 columns. Right? Department ID is basically the common column here. So cross join is nothing but this row, the first row, will be joined with row 1 and 2 with the second table. Similarly, second row would be joined with 1 and 2. So each row from table 1 will be joined with every row from table 2. So your end result will look something like this. So you have 1A joined with sales and marketing, right? And then 2A2 joined with sales and marketing. So every row, if you see, every row from table 1 is joined with every row with table 2. Includes rows from both the tables. So this is a very high level overview of inner joins, where we just take common rows. Outer joins, which basically has multiple things. One is left outer join, where we say take everything from left hand side table, and whatever does not match with the right hand side, put nulls. Similarly, right hand side, right outer join is the exact opposite. Then we looked at full outer joins, and then we looked at cross joins. So don't worry, let's look at a few examples now. So in the last few sessions, we looked at joins, right? And we looked at what is an inner join, what are outer joins, what are the types of outer joins, and we looked at a few examples. So we covered these concepts more conceptually, right? We looked at a couple of tables, and then we looked at how the results would look like. What we're going to do now is actually write some queries. We're going to look at how inner joins work, how to join two tables, and stuff like that. So let's actually take the same examples that we covered in our slides, and what I'll do is I'll actually create those tables, insert some values, join those tables, and so on and so forth. So some of the queries that we look at here, like something like creating a table, inserting values and stuff like that, might be more repetitive for you. So if you feel it's too boring, feel free to forward it until the point where you actually reach the joins part or the outer joins part, and so on and so forth. So let's get started. So when we looked at joins, we looked at something like this, right? We looked at two tables, and we said that when we join these two tables using a common column, what we get is the common rows between those two tables. So precisely, let's do that. Let's create two tables. One let's call it like my employee or something, another my salary, and let's just insert 3 rows in it. And once we insert them, let's look at how an inner join output will look like. All right. So let's go ahead and create a table, and I'm going to call this table as, say, my employee. So I'll say create table my employee, and let's say it just has 3 columns in it, and I'm going to call these columns as employee ID, and that can be an integer. Then you can have a first name that can be a variable character 20, and then a last name. Simple stuff. So just 3 columns, and just want to make sure that I spell things correctly here. Okay, now let's just put all these in our AdventureWorks database, and later on we can remove them. So I'm going to create this table. Oops, and let me make sure. So these are 2 options in SSMS wherein you can export the results to a file or a grid. We'll just export it to a grid. All right, so we have a table. Now let's go ahead and insert some rows into it. So insert into my employees. Values, and then what do we want to insert? Say 1 Michael Scott. All right, and I'm going to copy it 3 times now, just to make sure we insert 3 rows, and then I'll have to make sure that I change these values. So let me do that real quickly. And all right, so we have a table, and we have about 3 rows in it. Let's just have a look at that table. Oh, there's an object, and let's go ahead and insert 3 rows and say select star from my employee. All right, we have 3 tables. 3 rows and a single table. All right, so now next what we're going to do is we're going to do the same thing for my salary. And again, if you feel that these are too repetitive, go ahead and feel free to skip this part. I'm creating a table called my salary. I'm just making consistent, and then again it's going to have an employee ID, and that can be an integer, and then it's going to have, say, salary, right? And I'm just giving it a float, so you can include decimals if you want, but that's not a point here. And again, the same thing, insert into my salary, and then the value should be For employee ID 1, I'm giving him $10,000. And then for 2 and 3, I'll give them like 8,000 and 6,000, something like that. All right, so we have a table and we have inserted 3 rows, and then let's do select star from my salary. So these are the 3 rows. All right, so pretty much we have the same table that we looked at in our example, right? And what I'm going to do is, just so that you can look at both the tables together, I'm going to paste them one below the other. So these are the 2 tables. Now, what will happen when we join both these tables via the employee ID? So it's going to give you all the common rows that both these tables have. So let's look at that. So I'll start off with select star, and again, I'm just saying we're choosing everything, but we'll go ahead and change this later. And I'm going to say from my employee, and generally we have to give an alias here. So the alias name can be anything, A, B, C, anything that you like. And now I'm going to say inner join, employee inner join with my second table, that's my salary. And again, I'm going to give alias over here. Once I inner join both these tables, I need to also tell them what is the common column between these tables. So can be A dot employee ID equal to B dot employee ID. Simple stuff. I forgot something. It's on A dot employee ID equal to B dot employee ID. Perfect. Now I'm going to remove this star, and I'm going to say that I need the first name and the last name from my first table and the salary from my second table. And incidentally, my first table is referred by the alias A. So if I do A dot first name, A dot last name, and my salary is in my second table, which has an alias as B, so I can say B dot salary. So imagine that you are joining 2 or more tables. You can easily refer to the various columns between these tables via this particular alias dot column name. Okay, let's execute this entire thing. You see that this is select star from my employee, this is select star from my salary, and this is how it joined. So three rows in both the tables, and the resultant is 3 rows in the last table because there were 3 common rows. So one thing to note again here is inner joins means it'll only give you the rows which are common between these 2 tables. All right, great. So we have some amount of knowledge in inner joins. Let's proceed and look at some outer joins. So I'm going to start with left outer join, and we're going to look at what we discussed when we mentioned about outer joins and left outer joins. When we discussed our left outer joins, we said that we have 2 tables, right? The first table is what we just created as my employee, and the second table is something that we'll create. But if you see that the first table has 3 rows and the second table has only 2 rows, what left outer join does is it takes every row from your left table and it takes all the rows from your right table that is common with your left table, and whatever is not common, it just marks as at null. So this will be the result. You see that the row number 1, 2 are common, so you find data from both the tables, whereas the third row is only available in your left table, so it could not find a corresponding match in the right table, hence it replaced by null. Let's see how it looks like when we write a query. All right, so we have our employee table. We just need to create our phone table. So I'm going to say create table my phone, and again, let's just keep it simple. Let's say employee ID as integer and phone number as integer. Okay, and then let's go ahead and insert 2 rows. Insert into my phone values can be 1, 1, 2, 1, 1, 1, 2, 3, 3, 4, 2, something like that, right? And then we say insert into my phone values for my second employee. All right, so we have a phone table. We have inserted 2 rows into it, and let's look at the employee and phone table one below the other and see how it looks like. All right, So we have the phone table, we have the employee table, and let's see how the syntax looks like and how the results look like when we do employee left join with phone. So the syntax is pretty much the same. Select star from my employee, and again you need to give an alias, so I'm giving it as A, and this time instead of an inner join I'm going to write left join with my phone, and I'm going to give it an alias on a.employee id because that's the common row equal to b.employee id, and instead of star I need first name, then a dot last name, and I need a dot b dot salary or phone number. Okay, so you see that we're joining the first table with the second table using a left join, and let's see what it gives us. This is your first table, this is your second table. It could match the first two rows, employee ID 1 and 2, employee ID 1 and 2, but it didn't find an entry in the third row for the third row, employee ID 3, so it replaced it by null. So basically what you're saying is whatever is in the left part of this clause, take every row. And if you find a match, well and good. If you don't find a match, put a null. That's the whole concept of this. So the same thing also applies for right joins. So let's just extend that same concept in right joins. So when we discussed right joins, what did we say? We said that we have two tables, and it's kind of the opposite of a left join. You see that in your table 2, you have 4 rows. In your table 1, you have 2 rows. And out of those 2 rows, both the rows are present in both tables. That is, those are the common rows, right? So when you do table 1 right join with table 2, it basically says take everything from table 2, and if you find a match with table 1, well and good. If not, put a null in the corresponding cells. So employee ID 1 and 2 common, yes, you got data from both, we're good. Employee ID 3 and 4, there is data only in the table 2, in the right table, so take that and put nulls for your left tables. So let's look at this. So we have the employee table right now, and we just need to create one more table called, say, parking, and then we can test this out. Perfect. So let's go ahead and create a parking table. So create table my parking, and then again I'm just going to create some columns here, employee ID integer, and then let's say parking spot can be varchar of 20. All right, and then what we're going to do is we're going to again insert some values. Insert into my parking. Values can be for employee ID 1, the parking spot can be A1, and for employee ID 2, the parking can be A2, right? So let's look at the employee and the phone and the parking tables side by side. Execute this, insert 2 rows, and then select star from my parking. All right, so table 1 employee, table 2 parking. What we are going to do, just for clarity, let me do it this way actually so that you can look in the same order. Okay, so what we're going to do is select star from parking or my parking and give it an alias A, but this time we're going to say right join with my employee B on, what is the common column is a.employee ID equal to b.employee ID. And then I'll go ahead and say from my first table I need the parking spots, from my second table I need the first name and the last name. Let's look at how this looks like. All right, the first table, second table, we saw that the two, when you say right join, everything from your right table is accounted for. Whatever it found a match, A1, A2, it filled in those, and whatever it did not, it basically put a null over there. So it's kind of, you know, if you understand left join, it's opposite and so on and so forth. Now let's proceed. Let's look at how a full outer join looks like. So kind of when we discussed full outer join, what did we look at? We looked at a table, we looked at a customer table and an order table, and we basically said that it's actually a combination of your left join and right join. That is, whatever is common gets filled up on both tables. Then kind of you look at from a left join perspective where you see that, you know, you account for all the rows, and then whatever matches you fill in, whatever does not match you put nulls, and do the same thing for the right table as well. So let's create these two tables so that you can have a look, right? And this is how visually it looks like. All right, so I am going to go ahead and create a customer table. So I'm going to say create table my customer, and then I'm going to say customer ID, and then what did we have? Customer name. Yeah, customer name. And then I'm going to just insert two sample values. All right, and I'm going to copy this and insert another row. Perfect. So we have a customer table and we have two rows in it. Insert into each. Oh, okay. I forgot a parenthesis. Okay. All right. And then we had a order table as well. So let me just quickly go ahead and create the order table. We had the order number and I think we had the order name, and then just a customer ID, which is basically your column where you can use to join your two tables. All right, so we have an order table, and then what we're going to do is insert into my order values can be 1, call it some order 1. And 1. Okay, just 4 values, 1 2 3 4. Okay, so we have 4 values now, and then what we're going to do is we're going to look at both these tables together. Oops. Okay, 2 rows in the first table, 4 rows in the next table. Okay, so how should the output look like? Let's look at it. Select star from your first table. In this case, it's a customer table. Give it an alias. And now you use the word full outer join, and then you use my order as the second table and join via a dot customer ID equal to b dot customer ID. And then I would like to look at basically everything, but you know, let's just use your column names. I need the customer ID and the customer name from my first table. Oops. And I need a couple of columns from my second. Let's take the order number and the order name. Okay, that should be it. And let's just format this a little bit so that you can see things more clearly. Okay. So the first 2 rows were common between both the tables. So that's why you find table from both the tables. But you don't find. So actually, let me do one thing. Let me just make it a little more interesting. I'll say truncate table my customer, and I will actually use a slightly different data. Okay, now let's see how things look like. Okay. Now you see there's just one row that is common across both customer ID 1 and customer ID 1. So that's why you find the entire data from both the tables. Next, it goes to the second row. 3, John. It puts in here, it didn't find anything in the right side table, it put nulls. Now, it does the same thing for your right side table. The first row, it finds common, so naturally it actually matched the columns with both the tables. And then for order number 2, 7, and 8, there are no corresponding entries in your customer table, so it put nulls. So it's kind of a combination of your left join and your right join. Okay, now before we conclude, let's look at our last concept, that is cross join. Cross join, what we said is if you have 2 rows from table 1, 2 rows from table 2, cross join will actually join with every single row, right? Table 1 will join with 2 rows, 2 rows for each row of table 1. So that's why you see that the rows start repeating. Again, best way is to look at an example. So let's actually look at these two itself, right? So we don't waste time creating another table. So we say that select star from my customer the syntax is cross join with my salary. And let's see how this looks. Okay, so my customer, you cross join with my salary, so that's why you're saying every entry has 3 rows, right? So 2 rows from the first table, 3 rows from the second table. So the first row, that is customer name Rakesh, customer ID 1, joined with every single row from your second table. Similarly, it took the second row, joined with every single row in the second table. So that's basically what is a cross join. And another interesting way to write this is something like this: my customer, comma, my salary, and it'll pretty much give you the same result. It's just an alternate way of representing it. So we looked at some few examples of how to join stuff, and again, sometimes it can be a little confusing, and it's just writing more queries and getting more used to it. Basic rule of thumb is look at 2 tables, look at what is the common column, and basically analyze what kind of data you need. Do you need just the common rows, or just the rows from all the rows from left table, all the rows from right table, and accordingly just apply our joins. And you can extend the same concept to multiple tables as well. You can write table A inner join table B on some common column, and again you can write inner join table C with again a joining column. So once you master this concept, it actually becomes really very interesting, and for data analysis, because you'll have lots of tables, and this will allow you to easily join each table, run aggregations, run summations, and so on and so forth. So I hope you enjoyed the concept of joins. See you later. All right, so we are at the end of the course now, and let's take a quick rewind of what we have done so far, and also quickly discuss about what are the next steps, what are the other things you could do in the BI stack, and what are the other trainings that I provide. First of all, we looked at database concepts, table concepts. What is a database? How do tables fit in? How data flows into it? We also looked at basic querying, right? How to create tables, how to create databases. We looked at select queries. We looked at create, update, and delete, how to join different tables, how to run some aggregations, how to run, how to manipulate dates, what are the date functions, and so on and so forth. So by now you should have you should be comfortable writing basic queries and playing around with data. So if you are maybe going for an interview which requires some simple T-SQL queries, this should pretty much, you should be able to get started with this one. Now, if you want to take the next step and learning more in the BI stack, the next steps would be definitely knowing more about stored procedures. It should be custom functions, not customer functions, triggers, views, temporary tables, and so on and so forth. And I will be releasing an intermediate course as well soon. That should give you a good idea of various things that you could do apart from just simple queries. And advanced concepts would be another series which would cover things like database tuning, query tuning, and so on and so forth. Like, what is differences between clustered indexes, non-clustered indexes, how do you tune them, how do you decide where to use a index and stuff like that. We'll also look at some CLR, C# CLR profilers, and how to load very large data sets, so on and so forth. So we'll look at a few examples in those where we actually load huge amount of data sets. The next, of course, is a different concept where we talk about ETLs. ETLs is nothing but extract, transform, and load. Is basically how to extract data from different systems, say CSV, Excel files, from an Oracle to a SQL to Oracle, or something like that. And that's where a lot of ETL concepts and stuff come into play here. Things like when you are transferring huge data sets, what should be a buffer size, what is your speed, what is the speed of your machine, and stuff like that. So there are different things to consider over here to optimize your extract, transform, and load. And again, we'll split it up into beginners, intermediate, and advanced courses. There are a couple of things we can do in reporting, majorly being SQL Server Reporting Services, or SSRS. And that's a Microsoft product, and what are the different reporting tools is provided, reporting facilities it provides. Tableau is another tool where I'll release a separate course where we can look at what are the different aspects, how can you create really good visualization by connecting to different data sources, how to quickly create reports, how to quickly create very professional quality reports, and so on and so forth. Sometime later I will start with some big data analytics as well. We'll start with Hadoop for beginners, how to get into just basic querying, what is Hadoop and stuff like that. We go into something intermediate, and then we'll go into some advanced concepts as well. So hope you like my course. Thank you very much for watching my course, and please provide me your suggestions and feedback as well. Thank you.